First things first, we have a USB cable that is micro B female and micro B male. What we actually want here is USB A, but nobody made cables that came that way. So here we go. Also, already have the soldering iron on and hot. So first thing we're going to do is gently cut into this cable, because we don't want to nick. We don't want to nick any of the wires on the inside. We just want to get the outside off. What's important to us are the red and the white. Since this is going into the Motorola Lapdock, which has a one of those, a micro B female, we cannot send the red, which is the plus 5 volt, we can't send that this way. USB is not expecting that on the other end. And so it's expecting to send 5 volts down the line. So one end or the other is going to have a bad time. Probably fry some electronics or something. Trying to get a view that's good for the camera. It's really hard to do. I don't know how these people on YouTube managed to do that. Have the sheath is loose in the middle here. I'm going to go down with it. So the next step is I'm going to have to remove it carefully. And without cutting myself, which I think is going to be a challenge. It's going to be really gentle, because if you cut through, you'll eventually cut through, but if you cut through too far, you're just going to have wasted some time, because the whole reason we're doing this nicely is so that we don't have to solder 4 wires, we only have to solder 2. So if you are really polite to this sheath and don't cut into it like I just did, you might not have to worry about it. Of course, you know, going blade first into the sheath is probably the wisest of ideas, but okay. Split that fucker right open. This metal sheath is just for shielding. You can't see it. I pulled it off before the camera had a chance to look at it. Son of a bitch. This little guy here wraps around the cable along the length of it. And we're going to look very carefully at the wires to make sure that we did not nick any. This is really hard to tell, but the color of the wires are white, green, blue, and red. Red is the 5 volt line. Red's got to go. If you're smart, you won't do what I just did. Instead, you'll go cut it up here rather than in the middle. Maybe I'll just have done it enough that you don't have to strip it. Oh. Yep. Wonderful. So the wire's already stripped because I started this wrong to begin with. So, when you plug this end is going to have 5 volts coming from whatever you're plugging it into, Raspberry Pi or one of these dock thingies, because we're going to plug it into that port. And so we want that, we'll have to take care of that, because we don't want that 5 volts just chilling there. So this is going to connect to our power supply, and if you use Raspberry Pi, it's just going to get into the USB cable. In my case, I'm going to go to a hopefully good enough to work Chinese-made USB-C plug, because that's what this dock has. I don't give a shit about any of those data contacts, but what I do care about is one of those is labeled D and the other is labeled G, which is kind of hard to tell. The next thing is ground, which is, oh wow, this cable actually has a black one. Not quite what I was expecting. Let me look that up. And there should not be that many wires in here. So, about the only way I have to test this is by cutting one and plugging it into the lapdock and seeing if I can get a 5 volt reading with my multimeter. So that's fun. So we are going to clip the black one, not the blue one. I'm going to clip it. You're going, oh god damn it, I gotta get better at this. So you're actually going to need to clip it in the middle-ish, maybe further in, whatever, because you will have to fuck with it. You're gonna have to reconnect it back to the other wire, which is why I'm reluctant to do this, but whatever. So, I'm going to use my strippers for my wire wrapping tool. Shove that in there. I guess I need some pliers to just give it a good old bunch. You get a wire wrapping tool at Radio Shack, which is where I got mine. But Radio Shacks don't exist anymore in most places, so you are probably shit out of luck. But if you have one, wonderful. I'm gonna tin both of these wires because I need to anyway. My soldering iron has been sitting over here teasing me for fucking who knows how long. So the way I like to do these little itty bitty wires is I like to put the itty bitty ball on my iron. Then I like to heat the wire up and get something to stick to it. Gotta be really careful though, because you don't want to burn any of these other wires. Because they perfectly fine. For now. The other thing is that you wipe off your iron people. It smells awful if you don't. Shiny tip means you're doing a good job. Really gross looking black tip like I had, bad job. Also, somebody's going to agree for the way I solder these things. Fuck you. The whole point is just basically because these are stranded wire, we don't want them to come apart when we're working with them over there. And what you're supposed to do is you're supposed to heat the wire up and then apply solder like that. It's just really hard to do sometimes with these tiny little guys. So it makes more sense sometimes to just deposit the solder on it like you're painting, which is wrong. You should never do that when you're working on circuits or anything important. But since we're going to go back and do these in a minute, we definitely do not want to mess with it. Like we don't want them coming apart while we're working on it. First of all, to make sure that we didn't cause a short, to do that, we go put the multimeter in the right mode. We touch the leads together, it should beep. If it doesn't, you're in the wrong mode. And now we check for a short. Should be no beep. If there were a beep, it would go beep. And that would mean you have a short. We don't have a short. So the next step is going to plug this damn thing into the Motorola Lapdock. And then I'm going to go back to voltage, but make sure it's on DC, which it is. I'll pull that out from under there. I'm going to check the voltage. Apparently, it hates me. .5 volts. Expecting 5. So let's open the lid. Perhaps it requires something to project to the screen. Fine. You're just trying to tell me I should change the batteries. Continuing this up. Why is it trying to measure amps? It's a fucking switch sometimes. If I wiggle it, it switches between amps and volts. Now we're measuring millivolts, and it hopefully will fucking stay there while I measure the fucking leads. If we pick the right one, we'll get 5 volts. Which we do, 5.05 volts, consistently. As we pick the right pair. We need to strip this one here. We do have to be careful though, because we don't want the ground connection, the negative connection, to contact the sheath, or this metal thing in the middle, which is part of the sheath. Realize what side the blade's on and use that to your advantage. So I'm going to go ahead and insert that right up there. You just pull straight out and it'll strip it. And it's a tiny little strip. Tiny, 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 but I guess that's really all we need. Don't breathe this. The next step is going to be actually wiring the second plug, because this is going to be a Y adapter, is what's going to happen. I don't know if I said that at the beginning. Measure out roughly the length of the cable here. And I'm going to cut it. Right about there. I'm going to throw the other half in a pile. And I'm going to go back over here. I'm going to take that one off. We're going to remember the black connects to the sheath, which we do not have on our nifty little Chinese USB-C adapter. We don't have that. So we're going to take this red one. Probably in focus, maybe. It's good. I'm going to take this white one, because we now know that using the black one is a bad idea. And if we had a metal, to solder to that was like, you know, shield or something, then we could use that. Maybe I can connect the shield inside of here to the shield inside the other cable. That would be probably a good idea if I cared about EMI at all. The important thing is we just don't end up with this touching anything important. You can touch things that aren't important. It's not anything important. Okay, so off with its head. Off with its head miserably. This thing is rusted as shit. So the plan is to tin these. White's going to be our ground. It's going to connect to the black. And because we have the sheath, why the fuck not? turn this thing a little bit. So we can do these, which I did not spin. I always want to spin them like that. Like, you want to spin them like that or something so that they get all wound together, and so you aren't like trying to do something impossible. So it also would help if I was using nicer solder, but I'm also using Radio Shack solder that I probably bought in 2004. So oh yeah. That was actually a hell of a lot easier than I thought it was going to be. Okay, so next steps. I'm going to connect the red to the red. We can do this a number of different ways. What I want is this to go this way, so I am going to put these together like roughly like that. One thing I can do is I can take and kind of just wrap them around one another. I have created a little loop and hook them together. Okay, let's see. So you want shitty little solder. We take part of this, and we, tape them so that you don't end up with a short anywhere, because that would be bad to have a short. So this is all more or less ready to be prepared and made ready to go. So put my hand in electrical tape. Tear off a little bit. Start here approximately. Also, I've already used the multimeter to test that everything is good. So I don't have any shorts. I don't have any. Everything works. I've plugged it into my Mac, and the connector works just fine. So, it should work for Continuum just fine, but we'll see. Next thing is just like an added bit of safety. So take some heat shrink tubing and just shove that on the end. It took a little bit of work to stick that on there. May not be able to. It may just be a futile effort. So what I'll do is I will go ahead and burn it. And I've lost the pink lighter. So obviously that's just rubber now. And let me clean that up because this is going to be something you want to show people probably. It's a little bit annoying, so clean that up a little bit and go into it. Burn it. So melt this plastic and that's what it looks like on the inside. Yeah, good enough. Okay, I'm going to turn the camera off real quick and test this once more, just to make sure it's not fucked up. Okay, so I have gone ahead and tested the cable. It's great. So I threaded some of this white heat shrink tubing, which is going to go on the end of this little doodad here at the bottom, which is the strain relief from this Chinese connector. You're going to thread all that together. That's probably way too much heat shrink tubing, but who cares? I cut it already, so whatever. And of course, this is the USB-C adapter, the USB-C plug rather. You can see it's super tiny. So I am going to have to use this camera as a microscope, which is going to be interesting, perhaps really difficult, but we'll see. What we're going to have to do first is we're going to have to tin that pad and that pad. That pad is labeled V for voltage, this one's labeled G for ground. Or V for VCC and G for ground. First thing, I'm going to turn down my iron to what it says to be 350 degrees Celsius, but I don't believe it. What was that, 400? And the reason is this is super sensitive electronics. I don't want to remove any of these resistors that come on the connector as it is. So I'm going to okay, good. And then go over here to that one. Okay, now, got it. However, I think I bridged that pin, so let me double check. I didn't. That's surprising. So, you see that pad and the resistor next to it are so close. Take our wires, and I have already added a little knot to the end, so it'll just stay in the connector a little bit better. Also, the connector is the wrong size, so it doesn't work as well as it should. So the very first thing I'm going to do is make these leads about the same length, and I'm going to cut off the end. And we just need a tiny amount of the tinned wire. So I got that going on. Damn, this super macro zoom is hard. So I'm going to cut off a good portion of this wire. Since these are pre-tinned, both ends are tinned, it should just be a matter of lining it up, applying heat, and being good. Is it on? Yep. That one's good. Now we do the same thing with the V connector. I can't stress this enough. If you happen to be someone that has a microscope, or you're going to do this for more than just once, don't do this to the DSLR and the shitty EOS utility app. It's just not highly recommended. Okay, I think it's connected and not bridged. I guess it's not bridged. Wonderful. Okay, so it's a really shitty connection. If this were a class, I'd probably get like a C for how good these are. I'm going to test this to make sure I don't have any shorts, and then I will be back. Okay, so this is the completed cable with the micro A to regular A adapter at the end, because that's what I need to plug it into my USB-C dock thing. This USB-C connector only provides enough current to basically keep the phone from completely draining very quickly, but does not keep the phone charged, which is something I'm looking to fix at some point, hopefully. But I have to look into the USB-C standard a bit more. For starters, the way that the USB-C charging infrastructure works is completely different than how USB works, and so it may require hacking open a laptop to make it do what I want it to do. So let me go ahead and give this a quick demo, and you can see that it works. Okay, so this is the dongle with everything plugged into it, and then you can see I've got it plugged into the back of the laptop. I'm going to go ahead and plug it into my phone, which is a Lumia 950 XL. And there we go. So it is Continuum, like you would expect, just fine. Working on this Motorola Lapdock.